Hello and welcome. I'm Katalin Bunyevacz, the Innovative Action Expert of the SUD EUI project. And this video is intended to be an interview and a video tutorial presenting step-by-step the technical and analytical work developed so far in SUD related to the setting up of the next use AI recommendation model. The content of this video primarily target urban planners, decision makers, GIS experts from other European cities who are interested in learning about data-driven urban development solutions. I especially recommend this video for those who are already familiar with the SUD project goals, concept and activities, and who are following our project. The next use AI is being developed as a decision maker support tool for repurposing underused or abandoned buildings in the city of Košice. The focus of today's discussion is specifically the data integration process and the saturation and proximity model, both of which serve as the key foundations for developing the next use AI tool. The analyst who will guide us through this work is Róbert Pollák, Senior Data Analyst from Creative Industry Košice, who is one of the delivery partners in SUD. Róbert, thank you very much for joining me today. As a start, would you please introduce yourself and your role in SUD?
Hi, Katalin, and thank you for the opportunity to present our work on the next use AI from the previous month. I am Róbert Pollák from Creative Industry Košice, Senior Data Analyst. I am responsible for development of next use AI tool, which is the integral part of the project, SUD. And its main purpose is to identify functions for the unused or underused buildings in the city.
As far as I know, the first step of the work on the next use AI was collecting data, updating existing datasets, and integrating these datasets into the GIS platform of the city. Could you please explain what type of data did you integrate and from which sources, and how would you describe the structure of these datasets?
Maybe I will start from the end by the purpose of next use AI. It is the tool that brings recommendations to the city about purpose of the building, and those recommendations are based on three pillars. The first pillar is government or policy goals of the city. The second pillar is public opinion and public needs. And the third pillar we are working on now is spatial recommendation data that analyzes the whole urban tissue of the city and find patterns in distribution of the services and objects within the city. And with deep neural networks and decision trees algorithms, we are trying to predict which service is needed in or is recommended in which location. And to do this, we need the rich data sources about location of every possible service or amenity within the city that provides some function to its citizens. And we collected like a huge amount of data from various sources. So the base data source for us is OpenStreetMap, and it's open database of amenities placed on the map. These data are somehow general, and when we are working with higher precision, we are using the locally provided data from the municipality. So our municipality has its own data sets of, for example, schools, healthcare facilities. So these are from regional level, and data about placement of some kind of services for the whole city, which are in higher granularity, like that open data have been provided. So we gathered all those data into some data points. I can show it on a map that about those objects and services in the city. We have like 33,000 data points from the city of Košice itself, And when we can see on the map, there is a huge concentration of data within the city, and we need to process in somehow and put them into context. So besides of all those object data, we collect also contextual data. Those are the data about environment, the slope of the terrain, about land use and land coverage, about population. We have some general data about population provided by Copernicus project from European Commission, and also locally provided data when we can get into higher detail to have the idea which person lives where and what the demography is located.
Yes. So one of the challenge you must have faced that the lack of data, or lack of quality data. How did you address such gaps or lack of information? What kind of data collection methods you applied to make sure that all information are available for the next Use AI?
Of course, we met with a problem with missing data or some errors within the data, especially from open source data sets. And we were cleaning them initially manually, that we were finding the errors and put it into data integration process, correct data. And then we developed our own system to identify the missing data, or gaps within the data, and put it into process that to do only one correction for each missing data and make it like somehow automatic to integrate all those missing data for every turn we are working with. We are running the process actually.
Okay.
But we also deep dive into another data sets if some data set is faulty.
You also the title of the activity is data integration or data source integration. What specifically means integration in this case? How you integrate all the data sets?
We have various kinds of spatial data, mostly spatial data, but some of them are kind of social data, social information. And to put it all together, we decided to put it on unified grid within the city. We split it into small hexagons. We use hexagonal grid developed by Uber. And we use higher resolution grid to make it really detailed. And all of the data which were available, we transformed into the grid, into each cell. Each cell holds some information or no information, that's fine as well. And also we connected all those hexagons on our grid with walking network from OpenStreetMap. And hereby we created some relationships between services in one cell and its coverage area behind. So everything now is on like one huge chessboard.
Could you please show an example for this hexa pattern? Or
here is the example of how does those hexagons work. The hexagon is ideal for some spatial analysis because one hexagon is distant from all the neighbors by the same distance, and it's great for increasing performance of our modeling and experiments. So these hexagons are really in high granularity, and as for connection of those hexagons, I can show it on the map. We can see that here is the example of walking network, that how those hexagons, their centroids, are connected to each other. And also in this dataset are gaps or some faulty data. And we developed our GIS platform. I will talk about it later probably. We can modify this walking network to our purposes and to clean the data and to have like real world and real-life experience of the data.
Okay, actually I'm also interested on the one hand in this GIS platform you mentioned, which is called City Inspector, and this is the platform, the city of Košice. And I'm also interested to learn from you more about this proximity and saturation model, where you apply this hexagon method or tool. What do you think? Which aspect would be logical to continue?
We can talk about the platform, platform, because initially we were working with some already prepared software solutions like ArcGIS or QGIS, and they weren't sufficient for us for the overview of the data and to data exploration and understanding and also interaction with the data. So we decided to develop our own GIS platform. It's called City Inspector. And as for the project SUD, it will be available for the city of Košice as the main tool for them to modify the data, clean the data, explore the data, and also have the analytic responses or results from the analysis and also reports for the city in the later stages of the project.
Okay, so you develop your own platform, which is also able to do analysis. So similarly in QGIS or ArcGIS.
Similar to that, and we wanted to add some sliders and some interactive tools for the users that were too complex for standard software providers, or maybe we weren't too patient to learn it. So we went into development of our own platform that could be used for other purposes for the city of Košice or for our transfer partners as well.
Thank you. Could you please show this platform on your computer and also some function of this platform?
Of course.
How you use it for the purpose of the project or also for other purposes? And what type of map layers are available on this platform?
Kind of in the early stage of development. We are heading into UX optimization phase, but the functionalities behind are already implemented. So firstly, the users can modify the input data that are in the tool. So when we were talking about the walking network, user can see or explore the walking network and check whether there are some connections that are missing between hexagons, and he can also add some new connections between and modify the whole network behind, which will have some implications probably for simulations and for data correction as well. So here we can add the edges of the network that will influence the outputs of the model, and also we can remove those connections easily and then save the data for new version. This is one part of the exploration. The other parts we can see some analysis of catchment areas. Here we have not this city. We can take city of Košice and see some catchment area of certain point of the map that can be calculated, and data about some amenity will be displayed. What is within catchment area of 20 minutes, let's say. This can be modified into another number, and we can see what kind of amenities are available within the catchment area. This is aimed for supermarkets, but we can change the view to some another. We can also making overlaps between some source points, and we can really work with catchment data on the walking network, and we will then add some another networks like bike network or public transport. And to go to some advanced analysis within the project, maybe we can then deep dive into proximity and saturation model that is really crucial for the next use AI analytical part.
I read that you are going to follow this 15 minutes concept regarding the proximity and saturation model. How this concept connected to this model or serve as the main concept behind your model, and also could you please introduce us these two models?
I will probably show it on my presentation that each service point within the city, it isn't just a point, it's a carrier of the function, and that function spreads into the area. It's like its functioning zone or sphere of influence. And this was this with connection with walking distance calculation was inspired by Carlos Moreno and his 15-minute city theory, let's say, or model. And after discussions personally with him, we came with two metrics that are crucial for each location within the city. One is the closeness of the nearest amenity or service point that influences the quality of the location, and the second is possibility of choice, so variety of same kind of services within the area, and these two combined really represent the quality of
their life of
the life, but service coverage quality of each point in each domain. So, like for some area can be strong in coverage by supermarkets, some by elementary schools, and each area has its own unique mix of those metrics. So we put it into mathematics, and we developed a proximity metric that weights closeness to the nearest possible point of service from each location within the city on the walking network, and is weighted by its distance. And the second one is saturation, that measures this possibility of choice of those services. And we then mix them up with some predefined key, which is called ProxSat, proximity and saturation, and that represents the quality of each place within the city. Regarding the coverage, serviceability,
closeness, and saturation, and the variety of services.
Yeah, it's on the whole phase of the city we calculate this metric for each type of service or group of services. So we have like 600 data points or 600 columns in our table that represent the coverage quality.
And you brought us some examples, right, on your.
Yeah, we can see it on
to show how these models looks like on a map.
Yeah, we can see it on the face of our partner city Celje that really great performance in counting because it's smaller city. Here we can see the ProxSat combined metric for each proximity and saturation of the supermarkets. It's category retail, grocery, supermarket, and we can then see how it performs in proximity measure saturation measure, that the possibility of choice is great in this area. All those hexagons here are serviced the best within the city because there are 3 service points within walking distance. Also in this area and this area. All those places where there is only one provider are in the darker color. And when we will switch to proximity, 100% proximity, and recount it, we can see those islands of yellow color are pretty small. And this represents the closeness to the nearest area. So for each data point, we have this certain kind of map, and some analyst or city official or strategist can see which part of the city are underserved or overserved or well saturated with this kind of service. And these metrics and this combination will have a large impact on our recommendation model in the later stages.
Okay, just one question about the GIS analysis the GIS tools you applied designing these models. What type of GIS analysis did you perform to produce the model, and which software you applied? Was it still implemented inside the city inspector, or that was just a place for visualization?
Those kind of analyses happen really directly in City Inspector on the back end of the application, and they copied our research process because we used Python scripting for performing analysis on the data. We export the data using the Python geospatial libraries that are included, and this helped us to directly embed all those analyses directly into the application, web application that is built on Python backend. So, of course, after some optimization, but what we used were generally Python analysis scripts and libraries that were developed by us or copied from some sources or inspired by some sources.
Thank you for explaining these models. Could you please summarize what are the main conclusions based on these models for the case of Košice? So do you have any initial results that if I look at the map of the saturation and proximity model, what is the main message I can already see and read from these maps?
Yeah, so proximity and saturation model serves by itself like an analytical tool to identify gaps in service coverage within the city. We were also using it in real life scenarios with our analysis for urban planning authority or for identification of some issues within the service coverage of the city. But there is also higher expectation of those models that they will enter the recommendation model, which is the end game of this spatial recommendation tool.
So your work on the data collection and data integration, and also the development of these proximity and saturation model, are the basis of developing the next use AI. Could you please explain what are the next steps in this process and how other activities of the project are connected and will be channelized into this work you are working on?
Of course, this data integration and exploration of data, modification data, and creating those analytical measurements are just the initial step and groundstone for the wider purpose. And this is the spatial recommendation model we are using. So in this flowchart, we can see that we are in the phase that we have those metrics of each object or amenity, and when we connect them with all those contextual data and put them into one huge table, we can then switch into prediction part of the process, and we use some deep learning algorithms and decision trees to have like two separate point of views on recommendation for each object or amenity for each individual hexagon within the city. So we can perform some gap analysis made by deep learning models that can find those patterns in the urban tissue and all those relationships between various variables in the model. So and after the prediction for each of the function within the city, we get the spatial recommendation, which is one of three before mentioned pillars for recommendation. This is the spatial recommendation. Then we will have the policy needs that will be gathered, and also the public needs that will be gathered by surveys or something like that. But these are parts of process that will be developed in upcoming months. We are working on them for now.
Okay, thank you so much. As this video is prepared to share the knowledge and the work you have done in SUD with other cities, could you please summarize what are your recommendations for other cities if they start a similar work? Could you highlight which could be the challenges, the pitfalls, but what are those good practices you recommend to follow based on the experiences from the last months working on this project activity?
The first part is having some access to the data, to the quality data. We can work with general purpose data, like from the open sources, but to put all those data into good use, we need some locally specific data and their understanding. And it will be great if those cities have already some person who is responsible for data gathering and can be partner for the discussion regarding those data, because all the other parts are obtainable, easily obtainable or provided by us, but those locally provided data are crucial for the next development and transfer to the other cities. And I would like to add that we also plan not only to have some recommendation tool for each city, but we have an idea to compare cities among each other, and there is a need for harmonization of the data, because some cities are in different states which have some different educational models and each segmentation of education, let's say, or social services, and it will be a really interesting part to harmonize those data into one single data set.
Okay, so the data quality is key, and also even if you develop a transferable method, each country has different system, and these method has to be adapted to those. So what would be the next steps in your work? How you continue the work on the Next Use AI?
We have already fast run through the process of special recommendation. In some sort, we are in the end of it, and we have some pilot recommendations. There is our next goal will be to integrate it with policy needs report and participation results with the citizens, and integrated them into one single coherent recommendation for the city officials or decision makers that has its own results, reasoning, and underlying data that will be provided to the city officials or decision makers, and to work with them on iterative process how to make this report comprehensive and really useful for them for their purposes.
Thank you very much, Robert, for guiding us through this work and sharing this technical analytical work. I hope it will be useful for other European cities. And in the next videos, we are planning to show the completed Next Use AI, and also we are planning to present another key digital tool in SUD, which is the Asgard participatory platform. So I hope this video could raise your interest, and stay tuned for upcoming knowledge and lessons, experiences from the SUD project.